Hello friends, today a little bit about the calculation of electrical circuit, more precisely about the equivalent resistance. So imagine that you have a section of an electrical circuit and you need to find the equivalent resistance of this part. I draw it now. I will give an example on a not very simple electrical circuit which consists of 3 resistors. Let's mark the points A, B, C and D. A, B, C and D. A, B, C and D. These are the nodal points. The connection points of the conductor should be indicated by nodal points. If there are no nodal points, then there is no wire connection. Further, when solving such problem, the resistance of the conductors themselves is not taken into account. Of course it is, but it is usually very small, much less than the resistance of the resistors. We must take this into account. Therefore, the potential of points A and C are equal to each other. However, the potential of points B and D are also the sum. Therefore, I will rewrite the scheme a little. I'll start with point A. Start with point A. Points A. The potential of points A and C are the sum. A and C. I am writing 1 points. A and C. 1 points. 1 big points. This is points A and C. Small points, big points A and C. From point A I get to point B to resistor R1. R1. The potential of points B and D are the sum and I mark them. B, D, 1 points. 1 points B and D. From points B I get to points C. From points B I get to point C, to resistors R2. 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 And from point C I get to points D from resistors R3. 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 So I got a parallel connection of the resistors. Well, the parallel connection of the resistors is defined like this. I'll write. Parallel connection. For parallel connection. It's parallel connection, parallel formula. It is necessary to sum up to a common denominator. Common denominator. And write common multiplier for each fraction. R2, 3, 1, 3, 1, 2, and multiplier. So after that you need to remember to flip the fraction and get the answer. And not art, simple note. Yeah. Answer. In a particular case, everything is made much easier if, for example, all the resistors are the sum, and then it's easy to apply this formula. For example, and this is, and flip up, the method is suitable for DC circuit without taking into account the reactive components of the AC circuit. That's all for now.